So now we start from page 56. Page 56, and here we consider this area that is a triangle. We consider this triangle. Now we want to and this is defined by two lines, and this is y equals to 1/2 of x, and this is y equals to negative 1/2 of x, right? So to determine, so let's say this triangle is put on the wall, and we have a nail here, and we fix it at point O, and this is on the wall. Okay, it is on the wall, and we fix it at point O. Now, and for this triangle, and we consider one stripe here. We consider one stripe. Now, for this stripe, for this area, the width of it is dx, and for the width of is dx, and we want to determine the area. Area is equal to dA here. Now, what is dA? How do we determine dA? dA, the area of this rectangle or this stripe is equal to what? And because this distance is, this one is x, because this is x, so this one is 1/2 of x, as this is 1/2 of x, right? It's okay. Now, so we have the height of the area is 1/2 of x plus 1/2 of x times dx. Right? Dx is the width of the area. So it is equal to x dx. This is the area. Next, and then we will consider next, what we consider next is weight. Leave one line empty here, okay? I'll raise things here. So if we know the area, and then we know we can determine the weight. And the weight of this area, but we need to know one thing first: density. So if you know the density, let's say density this is the kg per meter square. Density per area. Okay. Let's say. If you know the area and we know the density per unit area, which is kg per m square, so we will know the dW is equal to rho g x dx, right? Now, if we know the weight, because weight is a force, this is because this is a force, and it has, so we have dW here, right? We have dW because it is put on the wall. 它在墙上哈 ，OK. It is on the wall, so we have dW here. So now we have if we have weight here, then it has a moment about O. And the moment arm is x. So we have the MO is equal to x dot dW. Does this sound logical? Now, if we have, so we are consider, because when we talk about center of gravity, we always talk about moment, right? We talk about centroid or center of gravity. We talk about moment. So we look at the moments here. This is the moment of this dW about point O. Then how about the total moment of the total area about O? We want to after we know this this area dA about O, and we want to determine the total moment of the total area about O. Is that okay? So we are talking about this because this by writing of moments of this about O, we are not putting any numbers here. We are putting x here. So by setting a different x, we can have this one, right? And then another x we have this one, another x we have this one, and this one, and this one, and this one. 1 plus 1 plus 1 strike plus 1 plus 1 plus 1, and then we go on. So in your high school mathematics, that it means we have integration here. We are simply putting this. We put an integration sign here. And this one is equal to, the moment about O due to one weight W at the distance x bar here. This is we talked about this last week or 2 weeks ago. Right. And for this one, and we are, if we do one area by one area by one area, we have this. It's okay. Because this one is this one, and then we do all areas. It is like this, with one integral sign here. Now, of course, we cannot. We cannot do this integration of x dw here. But what do we know? dw is equal to rho g x dx. Therefore, we have here rho g x dx here. We dw and then we put it in x rho g x dx here. It's okay. Now I think you know how to do it. I mean, you know how to do it now. And for dx here, because our this is x, so for doing the integration, we are not doing from minus infinity to plus infinity. No, we are not doing from minus infinity to plus infinity. We are only doing our integration in this area because the width of the whole triangle is only 1 unit from from x equal to 0 to x equal to 1. There is no area here. Okay, we don't need to do the right hand side. We only need to do the integration from here to here. Therefore, we have a definite integral here from 0 to 1 here. Now, if you can, and for this one, it is equal to this one. And if you have forgotten the if you have forgotten how to do integration, and it is here, and take a look. Okay, and then we have and the W is equal to rho GA here. W is equal to rho GA, and of course A is equal to 1/2. The total area is 1/2, so I think this one can go to this one, and by some mathematics you can do this one. You can work it out that x bar equals to 2/3. It is somewhere here. Oh, here. Okay. It's okay. So the logic is like this.
就是说那个逻辑大概是这样子跑了，所以大家回去先看，大家回去看一下 ，OK 吗？应该我不知道，大家回去看一看，如果有什么问题的话再问。最少我是觉得应该那个逻辑是在这里。大家有听过那个四字成语是理直气壮吗？我经常开玩笑说，有时候老师是里外气壮。 就是说，老师在讲一些奇奇怪怪的话，就讲的很有刺激的。然后大家回去复习的时候就会怪怪的。那回去看一下 ，OK 吗？但是这边应该是 OK 的。
有问题再问我。Wait, is that okay? Now we go to the next. So. Now we are using integration to do some physics problems, and now we want to do something new here. For example, if we have a line, suppose we have something very light, and then we have a line here, and it is made of like metal, something like that. And we want to determine the centroid of this. We want to determine the centroid of this line. Okay. But before we before we determine the center of this line, we want to determine the length of this line. Is that okay? We want to determine the length of this line because it is, of course, if it is a straight line, you know how to work. You know the length of the line. But if it's a curved line like this, so what is the length of this line? Now, and we are doing like this. We are working the problem like this. We have let's consider the length of a short section, delta S here. One short section here. And for this short section, delta S, of course, it has a component in X direction and it has a component in Y direction. For this delta S, of course, if you take this part as delta S, then we will have. If we have delta S here, then delta X and delta Y is like this, right? For each section delta S, we can get one delta Y and get one delta X. What's the value of them? I don't care, but we have one value of delta Y and one delta X. Then we can determine as delta S is like this, right? And for delta X square and plus delta Y square and square roots of it. You know square roots, right? And I forgot if I mentioned this. And of course, if we have this thing and we can rearrange, we can put it in this way, and we put delta X to the outside, and then we put it here, and then we have divided by delta X here, right? Now, for this is the length of a short section. This is the length of a short section, and then the total length of the whole line is the addition of this short section and this section and this section and this section. So the total length of the line L is equal to integration of delta S, and which is equal to this one. It's okay. Then so we can determine the length of line AB using this equation. The length of the line. Now, after we determine the length of the line, then we want to determine the moments of the line. Let's say about x-axis. We want to determine the moments of the line about x-axis. X-axis is here, of course. And for this, if we want to determine the moments of a short section about x-axis, and the moment of is y. It's okay, because we are taking the moment about this x-axis. So the moment and this section is here. It's okay. Now, and we have momentum y here. The momentum is y. So the moment of a short section about x-axis dm is equal to y times delta s, and because you can assume there is a force going in some direction. Okay. Therefore, the total moment of the line about x-axis is this one. M equal to this part, and then we do the integration, because delta S is equal to this one, right? We know delta S is equal to this one, and then we, or should I write it down? Right, something like this. So this is for one short section. This is for one short section. Now, if we want to know the moment of whole line about x-axis, and we work it out like this. This is we do it by integration, and we have of course, if we know the length of the whole line, then of course we can use the centroid to determine the moment. Of course, it's okay. That is from here we can work it out like this. And for this part is we are using that the one on top left hand corner. That is this is how we use this idea to put it here, and then m is equal to y times L, y bar times L. This is the centroid. Now, if you are ready, then we go to the next page. But take your time to copy this. Now, if you are okay, then we go to the next page. Okay, and so let's go to the next page, and I will work out an example. Sample problem 5.5. And determine, so we, and from, you need to remember I think you need to remember the answer of this question, right? And determine the location, determine the centroid of the arc of circle here. And this arc of circle is I mean this one. It goes from angle minus alpha to plus alpha. Now, of course, it has a the centroid should have the answer like x bar and y bar, right? Centroid, it is a point. But of course, we know that y bar is equal to 0 because it is symmetric about the x-axis. So, and because this is the x-axis, we let this is the x-axis and this is the y-axis, and the area above the x-axis is equal to the area below the x-axis, and they are of same shape. So it is symmetric about x-axis. So y bar equal to 0. That means the centroid is somewhere here or somewhere here. Okay, it is on the y-axis. It is not. It cannot be here, right? The centroid cannot be here, or it cannot be here, or it cannot be here. It has to be on x-axis somewhere. Somewhere here. It's okay. Now, the next point is where on x-axis? Where? Here, here, or here? And this is a line here. So, and suppose let's say x bar is here. Let's say x bar is here. Now, and the total moment is by doing the moment is xl. If we consider the total length L and then we multiply by the moment arm x, and the moment is x bar L. And if we do it a bit by bit by bit, then it is we have integral of x dl, right? Now, and of course from the last page we have something like this. Right? But for a circular, but this is so can anybody remind me the equation of a circle? Equation of a circle is this. You can say y is equal to r squared minus x squared. Am I right? So y is equal to this. Do you want to determine the derivative of this one? I don't actually. Do you want to determine if we have the equation like this? Do you want to determine this? I don't. It's quite difficult. So, or it is easily. We easily make mistake with this one. So we do it another way. Now, we start from here. X bar L is equals to integral of x dl. dl is this part, right? And then we have x here. It's okay. And then we have and for another part here, then we have x dl here. Let me mark it down here. X here and dl here, right? It's okay. We don't want to put DL in this method, but we have another way of doing this. We consider this one. DL, we mark two lines here. One is here and one is here. For this small angle, we have d theta here. So can we write dl in terms of theta? Can we do this? If we know d theta, if we know the angle d theta, can we write the length dl? Yes or no? If we know d theta, if we know this d theta, can we know dl? Yes. So because dl is equal to r d theta. Next, we want to determine the total length of the arc, the length L here. So what is the length of this line here? What's the length of the line here? I think you learned it in high school. It is 2 alpha times r. It's okay. Now, and how about x? Can we write x in terms of theta? And theta is we take this as positive. Okay, theta. X is if we know the angle theta. If we know the angle theta, can we know this distance x? The answer is yes, and x is equal to r cosine theta. Let's say we put it here r, and then this one is r cosine theta. It's okay. Now, if we get these three things, and after we get these three things, we look at the equation again. We look at the equation again, and of course, x bar is we look at the equation on the top left hand corner again, and x bar is unknown, of course. Sorry. L is known, x is known, and dl is also known, right? The only unknown in the equation now is x bar. There. So we have some way to get that. Now we have therefore we have x bar times 2 alpha r, which is L, is equal to minus alpha to plus alpha R cosine theta times R d theta. This one is, oh, sorry, what have I written? R cosine. This one is x, and this is dl. Of course, because our R goes from minus alpha to plus alpha. So we are only doing our integration from minus alpha to plus alpha. It's okay. So if we suppose we are okay with this, and therefore we have minus alpha to plus alpha r squared cosine theta d theta. Then it means we have r squared sine theta, and from minus alpha to plus alpha, which is equal to 2r squared sine alpha. Because the integration of cosine is cosine theta is sine cosine theta is sine theta, right? Now, what do we have? We have this one, and we have this one, right? We have that one, and we have that one. So, what should we do? And we simply put them together, and then we can get x bar. X bar is equal to 2r squared sine alpha divided by 2 alpha r, which is equal to r sine alpha divided by alpha. And that is the thing you need to know at examination. It's okay. This is the thing you need to know at examination.